I have done this multiple times already. So between helping you guys and also writing out my own um, solutions, this is something like what you should get on your calculator. Okay. And this intersection point right here gives me negative 0.31453, comma 0.13412. Now, there are multiple solutions on this. We pick this one specifically because, so if you notice, both of these were in terms of A. Our point A is here. So our intersection needs to be at this X value on my solution graph. So this was the closest one to that. That's why I picked this particular intersection to look at. Um, there will be multiple places because this is sinusoidal. There will be multiple places where it has the same slope as this other graph. But we're specifically looking for the place where it intersects that point. So then this ends up being my A value. And this right here is basically the A value subbed into either this or this. And so this is my value of your slope of MT. Okay, so this is your final solution. Okay, so that was 5. We're on a roll. But number 8, man, guys, number 8 took me a lot of paper to write out. Hopefully I can shorten it down. I think I will be able to because on when I'm videoing it, I can just say all the things that I wrote down on the paper. Okay, so now number 8 is a totally different type of question. So there were a couple of questions like the last two, and then there were a couple of questions like this. 7 was definitely easier than 8, so I'm going to go ahead and show you how to do 8. So it gives you this general polynomial, cubic specifically. Okay, and it tells you that it has a minimum at 3, comma negative 22, and a point of inflection at 1, comma negative 6. Okay, it doesn't really matter that it specifically tells you that it's a minimum. All you need to know is that that's like a stationary point. Okay, so from this, we can get 4 pieces of information. So we know 4 things. Basically, you're getting 2 pieces of information from each of these. Okay, so the first thing we know, split it up like I did in the other one. So the first thing we know is that the point 3, comma negative 22 is on the function f of x. Because there's a minimum here, this has to be a point on the original function. So this means that negative 22 should be equal to 27a plus 9b plus 3c plus d. Okay, so this is one equation. The second thing is that this point of inflection is also on the function. So 1, comma negative 6 is on f of x. So this means that negative 6 should be equal to a plus b plus c plus d, because 1 times all those things is just those things. So this is our second equation. Now we want to dig a little deeper for equations 3 and 4. Because this is a minimum, that means it's a stationary point on the function. So this means that at this x value, my first derivative should be 0. So f prime of 3 should be equal to 0. And this is because we have a min at the 3, negative 22. Okay, so f prime is 3ax squared plus 2bx plus c. So this means that 0 should be equal to 27a plus 6b plus c. This is our third equation. And then similarly, we know because there's a point of inflection here, our second derivative should be 0 at this x value. So f double prime of 1 should be equal to 0. And this is because there's a point of inflection at 1, comma negative 6. So let's find the second derivative. F double prime of x is 6ax plus 2b. We're finally cutting off some variables. And so when I sub in 0 for f double prime and then 1 for x, I get 6a plus 2b. So there are 4 equations. Now, okay, so what I did was I tried to get both 1 and 2 in terms of only C and D because these bottom 2 have A and B in them. I figured I could like use this to solve for like C in terms of or A or B in terms of C, and that in turn use that to define the other A or B variable. Okay, so that was the goal here. So first, this one is the simplest one to work with. So I solve for B. So solve for B, and this is in equation 4. Okay, so I end up subtracting the 6a over it and dividing by 2. So I should get that B is equal to negative 3a. Then I subbed this into equation 3. So sub B into equation 3. So I should get, let's see here. 0 equals 27a plus 6 times negative 3a plus c. So this means that 0 should be equal to 9a plus c. Okay, so now I have b in terms of a, and I can rewrite this so that it's a in terms of c. So like if I solve for a, I'll get that a is equal to negative 1/9 c. Okay, so I have b in terms of a in terms of c. That means I can get both of these variables in terms of c. Okay, so I want to take this one and I want to rewrite it in terms of c, negative 1/9 c. So this means that I'm having 1/3 c as b. So now I have both a and b in terms of c. So I can use these in equations 1 and 2 and sub in for a and for b, leaving equations 1 and 2 only in terms of c and d. Okay, so I want to sub those into equations 1 and 2. So for equation 1, I'm going to end up with, let's see, flipped my page too quickly, I guess. Negative 22 equals 27. I want to sub in for my a, so negative 1/9 c, and you'll see that these end up really nice. 3c plus d. These two end up canceling out with each other, so you get that negative 22 is equal to 3c plus d. Now for our second equation, we had negative 6 equals negative 1/9 c plus 1/3 c plus c plus d, which should give me negative 6 equals 11/9 c plus d. Now I have two equations in terms of just c and d, which is super great. So I'm going to solve each of them for d so that I can stick them in my calculator because this is calculator active. So d here is negative 3c minus 22, and d here is negative 11/9c minus 6. I would sub both of those into my calculator, and when I do that, I'm solving for c because that's the x that you're putting into your calculator. So when you do that, you should get that c is equal to negative 9. You can sub that back into anything. So this is from my calculator, putting that in. Then d should be equal to negative 3 times negative 9 minus 22, which ends up giving you 5. So my d is equal to 5. And now I have c right here. So I can just sub those back in to my equations where I had a and b in terms of c here and there. Okay, so this means that a is equal to 1/3 times negative 9. B is equal to, oh, did I do that wrong? I did. This one's B. This one's A. A is negative 1/9 times negative 9. This means that A is 1. This means that B is negative 3. Okay, we're so close to being done. So now When I sub this into my function, I get that f of x is equal to x cubed minus 3x squared minus 9x plus 5, meaning that f of 5 was 10 when you sub all that in. Okay, so hopefully that made more sense. Also, hopefully you paused through this to make sure that you understood what I was saying. I was going very quickly. So message me if you have more questions about this. I miss you guys a lot. I'm sorry that this was apparently more complicated than you thought. Please post on the discussion board for today and tell me if this uh, was if explaining it made you feel more confident about it, or if you still just feel like these are really unfamiliar concepts. We probably do need to go back through and just do like a basic calc review. So let me know how you feel and what you guys need. All right, I miss you guys. I love you all. I'll talk to you later. Bye.